Hello, this is eSpin Adam. We're happy to assist you with the upcoming presentation. Let us know if you need any help, and we'll be glad to be of service.
Security principles in DevSecOps.
Integrated security involves embedding security measures into every phase of the SDLC.
Rather than applying security as a final step, it becomes a continuous practice, influencing every aspect of development and deployment. Implementation of integrated security include planning, design, development, testing, deployment, and maintenance phase.
The first phase is planning phase.
The security requirements are established alongside project goals.
It defines threat models to understanding potential risks and integrating security objectives into the project's scope. The second phase is design phase.
Design phase includes implementing data protection mechanisms, secure communication protocol.
The third phase is development phase.
Development phase includes secure coding practices are adopted to prevent common vulnerabilities like SQL injection, cross-site scripting, XSS, and buffer overflows. While the developers use tools for static code analysis to identify and rectify issues early in the coding process. The fourth phase is testing phase. Testing phase includes security testing is embedded within the testing phase. The fifth phase is deployment phase. During deployment, security configurations are applied to ensure a secure environment. This includes setting up firewalls, configuring intrusion detection systems, and enforcing access controls. The deployment process is monitored to ensure that security policies are adhered to.
The sixth phase is maintenance phase.
Maintenance phase include post-deployment continuous security updates and
continuous monitoring.
It refers to the ongoing surveillance of applications, infrastructure, and network environments to detect and respond to security threats in real time. It is essential for identifying vulnerabilities, unusual activities, and potential security incidents as they occur, ensuring timely responses to mitigate risks. Implementation of continuous monitoring include application monitoring, infrastructure monitoring, and incident response. Application monitoring consists of tools and techniques, anomaly detection, and example.
Tools and techniques.
Deploy monitoring tools to keep track of application performance, user behavior, and security logs. Tools such as Application Performance Management, APM, and Security Information and Event Management, SIEM, systems, can be used to collect and analyze data.
Anomaly detection.
Implement mechanisms to detect unusual behavior, such as spikes in traffic, unexpected changes in user behavior, or abnormal application performance. This can help in identifying potential security incidents like data breaches or denial of service attacks.
Example is:
a web application monitoring tool may track user interactions and detect.
Infrastructure monitoring consists network traffic analysis, server health, and example. Network traffic analysis. Use tools to monitor network traffic for unusual patterns, such as unexpected spikes or abnormal data flows.
This helps in detecting potential security breaches or system compromises.
Server health. Track server performance metrics, such as CPU usage, memory consumption, and disk I/O. Monitoring these metrics can reveal signs of performance degradation or potential security threats. Example is:
a network intrusion detection system, NIDS, monitors network.
Incident response consists automated alerts, response mechanisms, and example. Automated alerts. Set up automated alerts to notify security teams of detected issues. Alerts can be configured to trigger based on predefined thresholds or specific security events. Response mechanisms.
Implement automated response actions, such as blocking suspicious IP addresses, isolating affected systems, or triggering additional security protocols. These mechanisms help in addressing threats promptly.
Example is:
an automated system might detect a potential SQL injection attack and automation in DevSecOps involves utilizing tools and scripts to perform repetitive security tasks, such as vulnerability scanning, code analysis, and compliance checks.
Vulnerability scanning is one component of automation. It divides into tools and techniques, CI/CD integration, and with example. Tools and techniques employ automated tools to continuously scan code and applications for known vulnerabilities.
Static application security testing analyzes source code for potential security issues, while dynamic application security testing assesses run applications for vulnerabilities. CI/CD integration integrate vulnerability scanning tools into the continuous integration and continuous deployment (CI/CD) pipeline. This ensures code is auto-checked for security issues every time it is committed or built.
Example: an organization incorporates SAST and DAST tools into their CI/CD pipeline. Each time new code is pushed, these tools automatically scan the code for vulnerabilities. If vulnerabilities are found, the pipeline halts, prevent the deployment of insecure code, and alert developers to address the issues. Code analysis is second component of automation.
It divides into automated tools, early identification, and with example. Automated tools use automated code analysis tools to review code for security issues, adherence to coding standards, and best practices.
Tools like SonarQube or checkmarks can identify potential security flaws and enforce coding standards.
Early identification, automated code analysis helps in identifying issues early in the development process, reducing the risk of vulnerabilities making it to production. Example: a development team uses an automated code analysis tool to review code changes before they are merged into the main branch. The tool identifies potential security vulnerabilities in coding, standard violations, allowing developers to correct issues before the code is integrated into the main codebase.
Compliance checks is last component of automation.
It divides into automated assessments, continuous validation, and with example. Automated assessments implement automated tools to perform compliance assessments and audits, ensure that applications and infrastructure meet regulatory and security standards such as GDPR, HIPAA, or PCI DSS. Continuous validation automate compliance checks to continuously validate that security controls and policies are being adhered to throughout the development and deployment lifecycle. Example: a company uses automated compliance tools to regularly assess their infrastructure against PCI DSS requirements. These tools generate reports and alerts if any non-compliant configurations or security gaps are detected, help the organization maintain compliance with minimal manual effort.
Shift left security.
Principle in DevSecOps that emphasizes moving security practices to the earlier stages of the software development lifecycle, SDLC.
Early involvement is the first components of shift left security. Early involvement includes security integration, threat modeling, and with example.
Security integration incorporates security practices from the beginning of the development cycle, including during the planning and design phases. This ensures that security considerations are a core part of project goals and not added as an afterthought. Threat modeling engage in threat modeling early to understand potential risks and design security controls accordingly. This proactive approach helps in identifying potential security issues before development begins. Example: during the initial planning phase of a new application, security requirements are defined alongside functional requirements. Threat modeling sessions are conducted to identify potential vulnerabilities and establish security controls before development starts.
Developer empowerment is the second components of shift left security.
Developer empowerment include tools and training, best practices, and with example. Tools and training. Provide developers with security tools and training to enable them to identify and address security issues during the coding process. Tools such as static code analyzers, secure coding libraries, and IDE plugins can assist in detecting vulnerabilities early. Best practices. Educate developers on secure coding practices and common vulnerabilities, such as SQL injection or cross-site scripting, XSS.
By understanding these issues, developers can write code that is inherently more secure. Example, developers receive training on secure coding practices and use Integrated Development Environment, IDE, plugins that automatically check for common security issues while coding. This helps in identifying potential vulnerabilities as code is being written. Proactive security is the third component of shift-left security. Proactive security include early detection, continuous improvement, and with example. Early detection. Implement automated security checks and code reviews to identify potential threats and vulnerabilities early in the development process. This includes integrating static and dynamic analysis tools into the CI/CD pipeline. Continuous improvement. Encourage continuous feedback and improvement by regularly reviewing and updating security practices based on new threats and vulnerabilities. This proactive approach helps in adapting to evolving security challenges. Example, automated security scans are integrated into the CI/CD pipeline, running each time code is committed. Developers receive immediate feedback on potential vulnerabilities, allowing them to address issues before the code progresses to later stages of development. Security as code involves treating security policies, configurations, and controls as code. This approach allows security measures to be versioned, tested, and deployed in the same way as application code, integrating security practices seamlessly into the development and deployment processes. Codified security policies include versioning, testing, deployment, and example. Versioning. Security policies are written in code and stored in version control systems. This allows for tracking changes, rolling back to previous versions, and maintaining a history of security policies. Testing can be tested using automated tools to ensure they work as intended and do not introduce vulnerabilities. Testing these policies before deployment helps in identify and address issues early. Deployment. Security policies are deployed along with application code, ensuring that security measures are consistently applied across different environments. Examples, an organization uses a tool like HashiCorp Sentinel to define security policies as code, stored in version control, and are automatically tested and enforced during the CI/CD pipeline, ensuring that security requirements are consistently applied. Infrastructure as code, IAC. Include code-based management, secure environments, and example. Code-based management. Manage infrastructure configurations through code using tools like Terraform, AWS CloudFormation, or Ansible. This allows for automated and repeatable deployment of infrastructure. Secure environments. By defining infrastructure as code, organizations can ensure that security configurations, such as firewall rules, access controls, and network settings, are consistently applied and easily audited. Examples, a company uses Terraform to define and deploy their cloud infrastructure. Security configurations, such as encryption settings and access controls, are included in the Terraform scripts. These scripts are versioned and tested, ensuring that secure environments are automatically deployed and maintained. Continuous security testing. Include integration in CI/CD, feedback loop, and example. Integration in CI/CD. Integrate security tests into the CI/CD pipeline to continuously validate security measures. This includes automated security scans, compliance checks, and vulnerability assessments. Feedback loop. Continuous security testing provides immediate feedback on security issues, allowing developers to address vulnerabilities before code is deployed to production. Examples, a development team integrates security testing tools like SNYK or OWASP-ZAP into their CI/CD pipeline.
As code is built and tested, these tools automatically scan for vulnerabilities and provide feedback, ensuring that security issues are identified and addressed promptly.
Thank you for watching our presentation. We hope it was valuable and informative. For questions, contact us at info@espincorp.com or visit our website. Thank you again and have a great day.